Back to STEM Online Academy. My name is Jason Masterakos, and I am the founder and president of STEM Online Academy. Okay, so we're going to be looking at specifically why smart students actually freeze on hard calculus exams. I repeat, hard calculus exams, not rote calculus exams. There is a major difference between doing real calculus and doing formulaic formulaic type calculus. Okay, so a lot of you smart students out there, you're not failing. You don't fail a hard calculus exam because you're just bad at math. You're failing because of the fact that the um, kinds of problems that you're used to doing when it comes to homework and practice are setting you up to fail. Okay, that's why you're failing. Okay. So I formulated several questions that I think are very important here. Okay. So let me think. Uh, the first question I think we need to discuss is, well, why can a student understand every lecture but freeze on the midterm? Okay. We're going to discuss question one, right? The question one's very important. Why can a student understand every lecture but still mess up on the midterm? Okay. Then question two is, what what is the first 30 seconds of a hard problem supposed to accomplish? There is a purpose that hard problems are supposed to accomplish. Okay, right? So there actually is a deeper purpose. And I'm going to discuss that as well. All right. Question three is, why is starting with an algebraic approach often the worst possible move for mathematical problems? Okay. And question four, how do you know, right, whether a problem is about problem's behavior, is about approximation, accumulation, infinity, whether they want you to prove something, or if it's an applied problem, right? Application to, let's say, physics, for instance, which is a common application of calculus. Okay. And question five is very interesting. Why does AI right? Often produce uh, often produce steps without knowing the problem's identity, knowing the problem's purpose. Why is it producing steps if it doesn't actually understand what's being asked? Okay, so we're going to discuss all of this. All right. So uh, the first thing when it comes to question one, let's answer question one. Okay, why can a student understand every lecture but still freeze on midterms? Okay, simple. You're freezing on midterms because your teacher or prof or instructor, whoever they are, a big part of it is because they're setting you up to fail. Yes, I repeat, your teacher, prof, or instructor, quite often, now it's not always their fault, sometimes it's your fault. Okay. Sometimes it is your fault. But quite often is because the teacher, professor, or instructor is setting you up to fail. And they're doing that by giving you homework that is either way too easy. See, here's the problem: way too easy or algorithmic. The two go together, actually, I think. Um, if the problems are easy, okay, first off, you can do a lot of them because they're easy, right? And you can just go through all of them really quickly. And they're usually very routine. It's the same type of setup, right? Maybe they ask you find the tangent line of y equals x squared. That's question one. Okay. Through the point, let's say 0, 0. Okay. And then you do question two to review for your midterm, right? And you think you have to do question two, find the tangent line of y equals x squared plus x plus 1 through the point 1, 1, for instance. Okay. Already you're seeing a common pattern. The only thing that's changed is the function, right? Between question one and question two. But the problem is they're asking the same type of question. Once you've understood that type of question, you should move on to another type of question. Okay. It should be non-routine. Otherwise, you're wasting your time for practicing for the midterm. Okay. It's not gonna it's not gonna give you anything doing the same types of problems. Okay. You have to really change it up. Okay. So algorithmic problems, they do not help you to do well on hard midterms. Okay. The only way you can do well on a hard midterm is doing a mixture of hard problems first off. Okay. And second, they have to be all non-routine from different areas. Okay. Question two. What is the first 30 seconds of a hard problem supposed to accomplish? What's the first 30 seconds that a hard, let's say, math problem is supposed to accomplish? Well, it's supposed to accomplish one thing. It's supposed to accomplish uh, making sure that you can think uh, fast and in a very structured and rigorous way in the first 30 seconds. Okay. Even if you can't, it's supposed to, the only way for you to improve, that's what hard problems are for, is to apply pressure on you, right? You shouldn't fear pressure, you should embrace it, right? Pressure and anxiety is something you should embrace because it's going to help you. It's going to force your mind to think. And as you think, right, you have to think in terms of logical ways, otherwise you're not thinking. And that's going to help structure your mind and be able to mathematically come up with the correct result, hopefully. A lot of times, no. A lot of times you'll fail. But the point is to facilitate rigorous problem solving skills, if that makes sense. Okay, that's the whole point of a hard mathematical problem. Question three: why is starting with algebra often the worst practical possible move? Well, it depends. If you have, for instance, you have an equation, a basic equation. Let's say find the limit of x squared plus x plus 1. You probably noticed that I like quadratics a lot, using quadratics as my function. Did something like that, yeah, algebraically dive right into it. However, though, if you have a problem solving question, like a big word problem, if you have a question on tangent lines, normal lines, or an applied physics problem solving question, or an optimization problem solving question, these types of problems, the algebra won't work. It won't save you because, right, algebra, right, is supposed to be the tool. A lot of people don't understand what I mean. Algebra is a tool to the logic. The logic and the reasoning is the framework. If you don't set up a problem solving strategy before using the algebra, then you will fail. Okay? You will instantly fail when it comes to problem solving questions. So you have to set up a framework. Right? And now for me, what I like to use is my famous systems technique that I've been using. Right? And it's responsible for giving me a 3.9 GPA in mathematics and physics. 3.9 GPA. Okay. It's something that I discovered myself. Maybe you need your own method, but my method is very effective. So what I've done is, right, step one is you want to visualize the problem. Okay. Visualize the problem. And what I mean by that is, let's say if you have a word problem, you need to draw a diagram, either geometric, graphical, whatever. Okay. Or if it's an equation, you can still use this, an abstract equation. Now, with abstract equations, um, you may not be able to draw it, right? Especially if the function is very complicated. Like, how do you visualize that? Well, what I mean by visualize is also, I mean, semantically understand it. So you want to translate that equation into words. So for instance, if you're integrating something that's really crazy, some really crazy function, and you don't know where to start, translate it into words as opposed to actually stepping right into the algebra, right? Because if you translate into words, you'll be able to semantically understand what is being asked. If you understand what's being asked, then you have a plan of attack of how to do the problem. Okay, I think that makes sense. All right. So step one, you want to visualize. Okay. And step two, you want to be able to model the problem. Okay. Model means, I don't mean you modeling. That would be weird. Uh, what I mean is, I want you to come up with a semantic framework. List what is important, not important, known, and unknown, and assign quantities to all these variables, all these things that you've categorized as known and unknown. Okay, to your visualization. From there, and when I mean visualization, I'm talking back about geometric visualization. That's where modeling comes handy. Okay, so back to the geometric visualization. If you have a problem that has to do with drawing, assign quantities. And then from you go to step three. And step three is to execute. The execution stage is now that you have a mathematical equation based off of step one, the visualization, and step two, right? You're able to create an equation. That is the hardest part when it comes to problem solving in calculus, but in math in general, actually, I think that's what really messes people up is those applied problems, and they're not able to extrapolate the important information. Okay, so that's one of the big issues actually, right? But it's a very important skill to have actually. All right. Okay. And then in the execution phase, yes, then you can apply the algebra. Then if you have a technique that you know, it's easy. Well, not every algebraic technique is easy. A lot of them are long. Some of them can be tricky. Even though the technique can be a bit more formulaic, it can still be complicated. Okay, so you need to make sure that you know your algebraic techniques inside and out when it comes to application problems. Okay, so that's for question three. I went very deep into answering question three. Okay, question four, I wanted to bring up is how do you know whether a problem is about the behavior, approximation, accumulation, infinities, proofs, or if it's an applied math calculus problem? Let's say that's applied to maybe physics or whatever else. Okay. Well, first off, if you have a question, let's say a problem-solving question, look for keywords. Right? Keywords will give it away. Okay. It's very basic. Keywords will do it. Maybe you have, and you don't have to be a big problem solving question. Maybe it's a short question, but it's in words, right? Let's say you want to, let's say you have a question that says, calculate the area between a concave up parabola, y equals x squared plus x, right? And another parabola, y equals negative x squared, concave down, right? By the way, I didn't automatically calculate those examples really fast in my head. Hopefully they intersect. But the point is that you have a concave up parabola, right, and a concave down parabola. They both intersect each other, so visualize that. Okay, and then it says find the area between the intersection points. There's a shaded area that you need to calculate. Okay, a problem like that. Okay, keyword would be area, right, because it says find area. Now that you know that the keyword is area, what mathematical operation in calculus applies to area, right? Linguistically, anyways. Linguistically, what mathematical operation goes with area? Integration, right? You have to. That means that you should be thinking that I need to integrate in order to find the area between the two curved shapes. Okay. Anytime when you need to calculate the area of a curved geometry, it has to be a curved geometry, right? I mean, it can work for a regular Euclidean type geometry, but If it's a curved geometry, you have to integrate. Okay, so that's an example of where you would actually how you'd be able to distinguish what is what. Okay, right? If it was a physics based problem, you know that the keywords would be, distance, time, velocity, and so forth, right? If it was something based on infinity, they may be asking you to find the limit as, let's say, n approaches infinity of some function, right? Or it can also be an infinite series, right? Maybe a geometric series that goes from n equals 0 to infinity, and the series is asking whether it converges or not. These types of things, they should be not that tricky to distinguish from, if that makes sense. Okay. All right. So that's question 4. And then question 5 is very interesting that I wanted to think about since everyone's talking about artificial intelligence is why does AI often produce steps without knowing the problem's purpose? Okay. Now, I know most of you just care about getting the right answer, but that's not what my channel is about. My channel is about um, not for you. First off, we don't do homework. We teach rigorous mathematics. Okay. So, and since my brand's philosophy is purely about rigorously understanding something very well, mathematics in general, um, we want to know why things work as opposed to just getting the answer. Now, knowing the why is hard, but it provides much more value than just getting the answer. Okay. So, in terms of, let's say, if you had an artificial intelligence doing a mathematical problem, for instance, okay, here's the issue. Okay, it may get the right. I'll give you two scenarios, right? It may get the right answer, okay, but there are problems with that. Okay, first off, it gets the right answer, and let's say you just take it, then you don't know how it got there, the reason why it got there, right? So otherwise, you're outsourcing the thinking to the technology. Okay, so that's already a big problem, all right? And case two is um, it does some math, and let's say it gets the wrong answer. You won't be able to know if it got the right or wrong answer because you don't know how it works or the why it works, right? The how and why is really important. Okay. So those are already problems if you just blindly use the technology without actually questioning it. All right. But back to the main point of question 5 is why does AI often produce steps without knowing the problem's purpose? Is because it's a statistical model. Now that means two things. It's a statistical language model, uh, which means that its purpose, it doesn't have its own consciousness or logical reasoning. It's just predicting the next word that you're using. Okay, that's how these language models work. They predict the next word that you're using, right? Based on a probability distribution, and that's it. Okay, it's all statistics and probability with the language models, right? They don't have an actual internal consciousness of of what's being asked. They don't understand what they're doing pretty much. So that's another issue. Okay, all right. So I hope you found this video thought provoking. Okay, and interesting at the same time, and hopefully provided value for you. Okay, that's my job is to make sure that I'm providing as much interesting content as possible. All right. Now, before I go, there's a few things I want to mention. Okay, is that first off, if you're if you're new, please like and subscribe. It will be handy. Liking and subscribing helps the channel because the algorithm, first off, is happy and pushes me up. So please like and subscribe. It would be very handy. Okay. So like and subscribe, please. Right. And number two, it is back to school. It's coming up. It's in August now. Maybe some of you are thinking about going, either you or your kids, whoever you are, maybe you're a student, parent, I don't know. If you have kids and you're thinking about this new school year, and if either your kid has trouble with math and physics, or you're a parent that wants to accelerate your child's understanding because they already have a strong foundation, but you want them to go even further. STEM Online Academy can help. We're here to do exactly that, is to help uh, all students, regardless of whether they have a lot of trouble or are gifted. We're here to help you uh, take your child's education to the next level by instilling understanding and rigorous thinking as opposed to memorization. Okay, that is a very different approach. Actually, we're probably the only tutoring company that does this. Most tutoring companies mainly go through an algorithmic type of homework type help. We don't do that, right? We focus on teaching you how to understand mathematics. Okay, all right. So understanding is the main philosophy of STEM Online Academy, right? Right. Teaching you how to the why behind everything in terms of math, right? Knowing how to justify things, knowing how to go from step to step. Now, it's not always, I'm not saying this is easy, but it's a necessary skill, especially if you want to go to university in STEM based subjects. Okay. STEM based. Maybe other subjects are different, but STEM wise, I can take my word for it. Uh, whether you become, you know, a computer scientist, mathematician, engineer, whatever it is, all regardless of what it is, all three of these things, or or in economics, they all require a mathematical thinking in order to be successful. Okay, so again, the link will be in the description below if you want more information uh, of all my services. And again, like and subscribe. It will be really handy. If you can another thing I want to mention, I will try to post 3 times a week now. Okay, I'm going to try to be a bit more present, especially if you guys like the content. The content will get more interesting. I'm going to come up with even more interesting content on the YouTube channel. So please like and subscribe, new subscribers, and I will see you next time. Have a great day, guys.